We're online again.
Right.
Welcome back.
Yeah, welcome back for the survivors at least. Sorry for it might be a bit complicated. I want to illustrate one of the use cases of Reactor with a web application and what you can do with that, and coupled to or mixed with other frameworks as well. So let's see with Grails. What's a great story with Reactor. So to put things back in context, the first fact is an HTTP request must return as fast as possible. You know that, otherwise it's just going to spin on your browser, and you don't want your user to switch. If the wait is more than 5 seconds, you can start counting your money because your audience is going to switch sites. Some sites like comparison sites, pricing sites are very relying on this pattern. They don't want the user to wait because if the comparison comes back too late, basically users have run away from your site. You don't want to do that. Well, you know that creating threads is quite tricky, and in general, concurrent programming is tricky because of locking, because of the performances, the memory it takes, etc. And the third fact is, well, not everyone is going to connect at the same time, except on Christmas, on Boxing Day, for instance, maybe, to buy something if you are a retailer. But usually, the burden is never constant. So you want to scale, if possible, dynamically. And the first thing you want to scale is the resources. You don't want to use more resources. You will see that it's cheaper on Amazon, for instance, to add more CPU power or more memory, rather than adding a new cluster member on Amazon, at least. After doing the math, you come with the question. So basically, I have to execute things in background. Any write operation must be background processing. I want the request to go back to the user as soon as possible. But at some point, it's going to be hard to manage. And how do I send back the data to the user? And at some point, I might change my scale, and I have a lot of users. So I'm a startup. I start with 10,000 users connecting every day or every week to my site. But at some point, I become Facebook, and I have 10 million users connecting every day. So at this stage, you may not want to refactor every time. Well, 10K from 10K to 10 million, you will probably need refactor. But you can increment smoothly if you have the right approach, the event-driven approach. So because you had a new level of indirection with the events, you don't call the method directly. You don't have a service where you say from the controller, my service, user service dot register user, and after that you run the page. No, you don't have this coupling. You will probably say something like send an event, and if there is something coming through on your user service, it's reacting. Otherwise, it's not. So if you want to add new services, you don't have to change your application. As I've said, you can just add a new module. It's quite agile. Laziness, it's key because you want to execute things only when the input is available. You don't want to block. Laziness is a synonym for non-blocking programming, basically. And well, at some point when you want to switch the kind of dispatcher you have to accept more data, you start with a simple dispatcher or even a synchronous dispatcher, you know. But you want to scale out at some point. Maybe your dispatcher is going to route your event to RabbitMQ, for instance. And just by tweaking the configuration, that's another aspect of event-driven, just by tweaking the configuration, I change the scale of my application. Well, just to make sure everyone understands, basically, the level of indirection is also called as an event bus. And if a service sends an event, using the publish-subscribe pattern, for instance, everyone is going to receive the event coming from the event bus, not directly from the service. If you add more services with more threads, you scale up. If you are on a cloud kind of architecture, it's basically because you switch your event bus to an extended event bus based, for instance, on RabbitMQ, well, all your application with all services inside each application are listening to the same event topic, for instance. So if the app sends a topic, an event on this topic, every application are aware because they are connected together through RabbitMQ, which is the level of indirection in this case. So for that reason, and because I've already talked about Reactor, we have a new plugin in Grails called Grails Events. It's still snapshot quality because I have to release a few more API and documentation. But that's, you could also rename that plugin Grails Reactor. Basically, it's a Reactor integration in Grails. So this plugin is not the first kind of this kind, in fact. There was another plugin called Platform Core. I don't know if some of you used Platform Core or used to have Platform Core in your Grails application. But it's an interesting plugin. And, well, I've participated to that plugin as well with Mark Palmer. And one of the API in that plugin was called Events API. And basically, from that, and because I met John Brisbane at this time, I told John, well, we have a few cool ideas in Platform Core Events API, but I think Events API could be applied to a lot of use cases and applications. See, there is a load of frameworks around that features. You have Vertex, you have Arca, for instance, but they all have an arid mindset about how you do things. We don't have something to be more flexible, a flexible dispatching strategy, a kind of APIs you won't find mixed together in the same framework like Promise and Stream. So a lot of ideas from Events API I've leaked into Reactor because, well, I wanted to extract a lot of them and make them available to all the Java developers. So, in a sense, Grails Event can be considered as Platform Core Events API. So, Platform Core minus all the other APIs. There is a configuration API, there is a tag API, a security API. But I wanted to just have Events API, which is more core and common to a lot of applications. Why a new plugin? Well, I've done things quite non-efficiently by this time when I created Platform Core Events. And using Reactor and rethinking from ground zero all the abstractions introduced a lot of new features as well. So, for instance, streaming and selector and queue. Before you could use the string as a topic, but now you can use any kind of selector as a topic, in fact. Before, every consumer aggregated data before replying to a producer. Now you can just stream data. So that's interesting. The fact it's a new foundation and extracted from Grails Reactor is interesting because I have a free committer every time now with John. And that benefits to other developers as well. And well, the new plugin is a new plugin back because some semantics are new or have changed. Well, last but not least, we are discussing embedding the Grails event plugin in Grails 2.4 and Grails 3 as well as a foundation for the new Grails applications. So that's also a reason why we have streamlined the plugin to be ready to be added in Grails core. So what can you do with Reactor and Grails events? Well, basically, the first thing is listening for plugin application events. Starting simple, notifying only in memory. And, well, there are also plugins to do asynchronous calls in Grails, but none of them use the disruptor and the kind of API we offer in Reactor. For instance, you have background thread or background processing plugin, something like that, which allow you to create a background thread or reuse a thread to do your write operation, avoiding the HTTP blocking. But that's it. We will see that Reactor and Grails event add other things. For instance, replaying back at some stage to the browser using some technologies like WebSocket or server-side events. So, first thing, if you want to start using the plugin, as I just said, it's not released yet, so it's built snapshot. And another interesting thing is it's a binary plugin, so you use it as a dependency in your dependencies block. It's not a plugin you can use using plugins and your plugin. Why is it a binary plugin? Not because I wanted it to be closed sourced, but because there are AST transformer. That means it needed to be precompiled to apply the transformation to your code. Because the plugin injects a few methods in your API, in your services, in your controller, but the injection is statically done. It's statically compiled. So if one day you add compile static in your controller or your service because you want your Grails application to be as fast as Java, for instance, could be, well, the events plugin is ready for that. Quick reminder, a consumer is the thing that accepts the event. We know that. And if you use a ring buffer, it's thread safe. So if you have a state in your consumer, you know that only one thread is going to mutate your data. So that means no locking needed. Selector is the super topic artifact we have. And as we have seen in Spring module, we can directly annotate method in a bin to create consumers. And the reactor, because it's an object as well, is a super object to have a dedicated consumer registry. So two different reactors won't have the same events. If you start using on blah blah on first reactor, the reactor 2 is not going to see it. So you can segregate your reactors for some reasons. We'll see one of the reasons just afterward. A reactor has a dedicated dispatcher. That's a reason as well. So if you have a reactor which does only synchronous calls, you want a separate reactor for that with a separate configuration. And if you want a reactor to do different kind of routing to your consumers, for instance, you have two consumers listening on the same topic, user registration. By default, Reactor is going to call all of them publish, subscribe. But you may not want that. You may just want to run Rubin because you want to scale up and you want the first available, the next one, to reply to you, to consume your event. So you can change this configuration saying, this reactor is going to use the run Rubin strategy instead of the default one, publish, subscribe. There is also a random strategy, which is faster than run Rubin. Run Rubin is, on big numbers, the most efficient way to load balance things. The most efficient is random. And that's also the first one. There is also the first run strategy. Reactor plugin creates for you a default reactor called Grails Reactor. You can override these settings. But by default, if you don't specify a reactor when you call the reactor method, it's going to send the method to that.
It's back.
Right. So one of the first things you can do with a Reactor in your Grails application is applying the event-driven CQRS pattern. So it's quite efficient if you want to have a separate service to post-process your data once you're sure there is something in your database. Because of GORM, the GORM is, as you know, the database abstraction in Grails. GORM is sending events every time you save, every time you read, every time you trigger database, in fact, you have an event. Well, with Reactor, you can catch these events and do things. For instance, save service is going to save your data user, for instance. And the post-processing service is just, in fact, a consumer listening on at selector after insert, after your data is inserted. So you have this decoupling, which is explored in this part in CQRS. I invite you to read it. Quite interesting. Sorry, that was wrong. So, another pattern often discussed in this talk, I guess, the modular architecture. So, say your main application, a Grails application, trigger a request event on every request. You have a separate plugin, notification plugin. You have a different lifecycle, a different team working on this plugin. It's a really true segregation at this stage. And this decouple module is going to consume request events. It doesn't matter, it's a plugin. It doesn't depend on the Grails application. It's just a plugin listening on these events. And that's it. You have this decoupling way. So team 1 is working on the main application. Team 2 works on notification plugin. The only need you have, only thing you need is a contract documentation saying that the event you receive on this topic is a user, for instance, or JSON data. That's another example of using Reactor in Grails. And another one, yes, the background processing is quite important. You want to request to return immediately to avoid losing users. Well, like me and you, I mean, this talk is so long, I'm starting losing you, I know. If I was returning immediately and you can leave the room, you will be happy. But now you're blocked because I'm blocking you. So you don't want that with Reactor. You can solve this issue. Unfortunately, unless you can run now, unfortunately, you can solve that now. Well, in the case of background processing, the only thing the Grails controller is going to do is just to call a request event using an asynchronous dispatcher, ring buffer, for instance. And, well, let's say the request service does long call to an external REST service, and that's the reason why you want it to be in a separate thread. So, in the old way, with the platform call plugin, for the ones who would know that, when you wanted to send an event, it's quite simple. The method is injected in all your artifact controllers, or services, even domain classes or bootstrap classes. So the event called the key, mail registration, and the user as a data, and that's it. You have different flavor to that method, and that was it. So the API has slightly evolved. It's still an event method injected. Well, now it's compiled statically, statically compiled, so that means injected even at compilation, not on runtime with meta-object programming. So now, by default, I can't remember if it was the default. No, it wasn't the default. On platform core, at least on the early versions, when you call event, well, the flow is keeping executing. In fact, it's non-blocking. And, well, if you want to listen or react on replies, you can use the third argument closure, and for instance, it is the implicit closure argument, which is a data sent back. And if it's n, for instance, we stop listening for replies. It's important not to forget, because Well, otherwise you will listen indifferently for replies. You have also the map notations as shown on the last comment. So that's it. That's a reason. You see, on new user param save, it's basically a controller method. You can guess. I'm sending an event, and that's it. That's all the thing the controller has to do. So the render view is not blocked and returned immediately. The cool thing. But maybe, and that's what we will have to answer in a second time, maybe you will have to notify the user when effectively the data has been registered or made registration has worked or something like that. So that was for the producer side. Now for the consumer side, that was the way you would do it in platform core, just for reference. So the things haven't changed a lot. You still use an annotation. You can still type your plugin, your method to listen for the envelope, the event type, instead of the data, if you want to get the headers, for instance. This kind of thing hasn't changed. You can see even by switching sides, it didn't change a lot. Just the selector, before it was called listener, now it's selector. It still used the method name as a default topic name. If you want to change that, for instance, you want to have multiple consumers on the same method listening to the same topic, you can't call the same method twice. So you might have to give an alias and then precise the topic on the argument. If you want to get the event type, which is the core envelope in Reactor that contains your data, you can get the from key, the to key, sorry. So where it goes, where it should go, and you can get the headers, as we have seen, and a few other informations. Another thing new with the plugin is the new artifact you can add in conf / blah blah events, which is the convention to create configuration for Reactor. So if you want to use multiple set of configuration, you have to include all the configuration and merge. That one will include default events. You can see by convention, we just use the property name of the class. Also, I told you the Grails event comes with a default reactor, and you can override settings if you want to, or add things directly. So in that case, I'm overriding the reactor configuration just to add an inline some topic listener, which replies test. Also, you can define your own reactor. You can see there is another type of dispatcher. I don't use type, I just use dispatcher, and I assign a new dispatcher, synchronous dispatcher. I could use a reference to an existing dispatcher, but that way is a way to show you that if you want to create your own dispatcher, implementing dispatcher interface, you can just use that and then assign this to the Reactor dispatcher. There is also an extension to enable your Reactor to accept GORM events. By default, your Reactor is not going to react on GORM event. That means you won't see if you listen for after insert, after delete, after update, you won't see this event working. In fact, by default, you have to enable it by using GORM true. Well, quick reminder, some things you have in Reactor is listening for arbitrary selectors. So I've talked about the URI selector, which is interesting to capture some data, but there is also another one interesting, which is the T-type selector, which listens for a specific key. That's interesting, a specific key type. So that's the mechanism we use to throw exception. If you want to know all exception happening in a Reactor, you just have to listen on T exception, or throwable was, and you will receive all exception. Another interesting thing, another method injected in your artifacts, the stream. So remember the stream in Reactor. We can create it automatically using with stream. With stream is going to capture every reply. Remember, we can do reply on a consumer. Where does go the reply? Well, with stream, is going to capture the reply and pass it to the chain, because it's a stream. You can pipe things. By the way, there is a new method I introduced there. I didn't show on Reactor slides, which is when. When is when an exception happens. You can listen for a specific exception or for all exception. In that case, I just listen for exception. I omit the dot class because it's groovy and it's cool. Well, the map, if after the reply you want to apply all the transformation, inline transformation, calling a specific service that only your producer knows about, it's cool to pipe all these operations directly from your producer perspective. Your consumer might not know about the fact you need to call an external service, but you want your event to do that after it has been dispatched, processed by the consumer. That's why the with stream is also interesting. There is a nice blog post from Netflix about that, for instance. They show how they aggregate multiple sources by using this kind of notation. Well, you will need to Google that. I don't have the URL in head. And by the way, if you want to consume and add a callback, you can just use .consume. This one is an interesting one because if you not, you can see it's a different signature, in fact, from the consume, the usual consume I showed, because it's not accepting a closure. In fact, it's accepting two arguments: a string, a selector, a key, sorry, and a reactor. That means all these things happening there are going to be forwarded to the reactor with ID browser. Reactor is a method injected for you to fetch from the registry a reactor. Remember, you can have different reactors for different purposes. That one is the reactor for the browser purpose. And after all these operations have happened, I want to send them back to the browser, maybe. We'll see in details how that will work. So the callback is the browser there. You know that Grails 2.3 comes with promise support and a few asynchronous flavor, interesting flavor support. By default, it uses gpass, Groovy-powered promises. But as soon as you install Reactor plugin and you don't explicitly disable the promise support in Reactor plugin, the promise factory from Grails switch from gpass to Reactor. So you create Reactor promise. And the Reactor promises are cool because you can pipe them. You can attach a lot of callbacks on different kind of stimulus. That's interesting to have a more powerful and comprehensive promise with Reactor. Another interesting thing is the dispatcher for the promises is something you can configure as well. You can see that maybe in Play applications as well. You can tweak the promise dispatcher. Well, that's the same way there. If you want to tweak the size of the ring buffer, because you define a size, remember, it's pre-allocated slots. So depending on your hardware, you will change this buffering, and depending on the data you stream. And then you just have to use the, well, that didn't scale quite well, but res equals long processing in a task static method coming from Grails promise support is going to return a Reactor promise. So the last block is typically standard Grails 2.3 coding, but just know that this returns a Reactor promise instead of a gpass promise. Well, I told you earlier, you can change the routing strategy, which is interesting. So in that case, I build a Reactor. If I call test, I will reply, well, it may be obvious to you. It will reply 1, 2, 1, 2, 1, 2, because it's from the Robin. If I left the default one, it will be 1, 2 every time. So, well, 1, 2, 1, 2. In that case, each call return or 1 or either 1, either 2. The platform core plugin had a lot of hook points where you can change things, extend the strategy. For instance, platform core used to have a vertex plugin. So when you use the event method, instead of going in memory and dispatching in memory with the default implementation, it's going to vertex event bus and send the event to this event bus and listen from this event bus. There is also event Spring integration, which transform your consumer into channel and service endpoint from the Spring integration perspective. So you can extend and even change the engine, but still keep the same semantics. So the Comb is now an extension as well. You have to use, as I just showed earlier, you have to use a Comb ext Comb true to enable the Comb support. So once you have that, other thing you can do in your services, which you select or to consume event, is, for instance, in that case, I use before validate. Every Comb data are triggering before validate. Well, when it validates data. So I use I consume on before validate. You can see it's inferring from the method name, the selector. And I use a reply to annotation. If I want to reply data to someone, I have to use, if I transform a method into a consumer, I have to use the reply to, because I'm not using the closure notation where I can just write reply. I'm transforming a method and doesn't support the reply method here. Equal, maybe, but not explored yet. If I return false in this before validate, that means every single Comb data matching book type are going to be failed. So it's going to prevent any book to be written in database. So once you have a Reactor-backed application, the interesting thing is, well, you might return your request immediately, but well, at some point your user might want to know how to, well, if the data has been written in database, it must show something in your page. He doesn't want to refresh every time to get this data back. So another interesting thing is to apply the real-time web pattern, which is still returning immediately to the browser, still triggering the async event, but in that case, we reply a new event, and using WebSocket server-side events or other kind of technologies like long polling, HTTP streaming, and all of that, you can just push the reply. So the browser, the guy behind this browser doesn't have to just type F5 every time or a command R. You just wait for the reply, some kind of a mechanism to tell him to say, oh, you're going to receive the reply. Like Twitter, for instance, when you post a tweet on Twitter web page, it doesn't show up immediately. In fact, it returns immediately, and then your timeline is updated. That, in fact, Twitter is behind a lot of these patterns. So that's the kind of thing you want to do. You want your application to be completely responsive and reactive to the user, because the user are going to be happy and stay on your site afterwards. So we have a plugin, Grails Event Push, which depends on Grails events, and use the extension mechanism in that plugin, ext, to add a new flavor to the plugin. It's backed by Atmosphere 2, which is an old Java streaming API, push API for your browser, supporting automatically fallback. If your browser is IE7, it doesn't support WebSocket, for instance, it's automatic fallback to serve HTTP streaming. If it doesn't support HTTP streaming, it might fall back if you want to long polling. So this adaptive protocol is quite interesting, and with the browser market today, you're forced to use this kind of technique. Either it's something like Atmosphere or the major challenger, which is SockJS. So if you don't use one of them, you might go in trouble, or you just discard a user base which is using an older browser, for instance. And also, Atmosphere 2 goes further, for instance, compared to SockJS, because it also adapts to the server. If you use Tomcat 7 0.26, for instance, or Tomcat 6, you don't have WebSocket. If you use Tomcat 7.0.42, you have, well, in fact, it's after 27. But if you use this version, you have WebSocket. So it adapts the protocol on the server side as well. If you use an I/O connector on Tomcat, it detects that and adapts to it. So that's quite powerful. It even works on Netty. Atmosphere works on Netty, and I plan to add a few things around that as well. Atmosphere is a great framework. The purpose of this plugin is to, in fact, if you think about how I'm going to expand the scope of Reactor to the browser, I want the browser to send event or listen for events from the server. So what you need to do in that case is, first, you need to create bridge between the client and your server, and you need to have a dedicated space to push data from the server to the client. So let's see that in details. If you want to try the plugin, the new version, which uses Reactor, is also on snapshot because we need to release first Reactor plugin. You can install it. Important fact is try to use a long connection friendly configuration. An I/O connector is a must-have, and today I think it's a standard one. If you still use blocking default HTTP connector and Tomcat, you might miss some performance improvements. The servlet version is interesting as well if you want to use the latest features from, well, in fact, it enables Atmosphere to use some of the features like detecting disconnect from the browser. Explaining just in a bit what happens with Grails events push. So first, your browser is finding the right protocol, negotiating the protocol with the server, and establish the persistent connection, whether it's a long polling connection, so a long HTTP request, or a WebSocket connection, it doesn't matter. The second thing you have is registering topics. So in your JavaScript code, you will start using code like on, and this is going to create a bridge for each consumer on your client side. So we will see that if your Reactor configuration have ext Reactor, ext browser with the name of the topic you want your client to listen to, that means the client is allowed to listen to this topic. It's, in fact, by default, it's a blacklist. You don't want your client to listen for every event. For instance, you have a mail registration event, which sends a few sensitive data. You don't want that script kiddie goes into your application page, add a few JavaScript call to just listen to every event coming from the server. So by default, it's blacklisted. You need to, well, you need to enable one by one the selector you want to propagate. And, well, the third thing you want to do once you have registered your operations is to notify from the browser to the server. That can be done with a post, for instance, HTTP post, but we have an API for that on the JavaScript side. And the last thing is your JavaScript side has to consume events, so the Reactor is able to push back data to the browser without triggering a refresh. So in details, in fact, I'm going to switch directly to the code base to show you more fun things. So let's see an example, and let's dig into this in details. So I have a simple started application, a Grails application. Let's start with the first example, the board. You might recognize that. The board is a simple way to draw things just using the mouse. So if you want to share this board with any kind of device, including an iPhone, for instance, if I want to draw things for my iPhones like that, I could do that. It's just a matter of propagating events from a browser to another, and the server side is the middle layer, the level of indirection between your browser. So, well, it's using Atmosphere on the client side as well, so it adapts. It knows it's an iOS iPhone device. If I push data then using WebSocket, by default, because I use Tomcat 742, and my browser is Chrome, I'm just going to refresh to show you the long polling, which is there. You can see it's a WebSocket extension. Maybe hard to spot on the screen, but it's truly a WebSocket. And you can see frame exchange between the server and your browser. You can hide, mask the frames by enabling binary support on the WebSocket, which is quite interesting. And, well, that's it. If you can even replay events, because you have a server-side part component in this application. You can capture events from your server as well, store them in map or in MongoDB or whatever, because it's JSON data I'm sending. And then if you want to replay them, you can just replay them. So let's see in details how does it work. So another cool thing about the plugin I didn't talk about is it works with reloading. So everything I'm going to do is done without restarting the application, because I don't have time to lose restarting my Tomcat application, etc. Even if it's Java and compiled code. So the first thing I have to do is basically listening on a set of topics I want to enable. So the configuration is simple. I have a test push event. It's an artifact creating the event configuration. I create, in fact, it's an existing reactor. I create a configuration for reactor, which use the browser, a convention. I can use a static name, but for convenience, I would just use the string. Browser is gathering all events coming from your browser. So that means if you want to listen for data from the browser, so post-operation from your browser, you have to listen on this reactor. You have to do reactor browser on and any kind of events sent by the browser. So that's listen for event for the browser, and the extension browser is enabling the bridge. So that allows the browser to be pushed by the server. And we have, as I said, it's whitelisting. We have to enable all these topics individually. So I use the selector mechanism. If I want to allow the browser to listen on every kind of topic starting with sample bro dash, I can use that because it's a selector. If I only want to specify a list, a dedicated list of things the browser can listen to, I can just declare the list. So my browser can listen on control, can listen on move, fire, leave. You can see there are other samples in that application I'm going to show. But basically, in all cases, this board is just listening for start row for creating the first point and drawing lines then. So I'm bridging the browser to the server, but see what I've done. I've done that in the browser, the from browser reactor. So basically, I've just plugged together the from side to the to side. So that means every event coming from the browser are allowed to the generated consumer here. And this consumer propagates that to the browser. So that's a simple way to propagate things. How I write JavaScript to do that? It's not rocket science because we have a dedicated API for that. If you use resources plugin, you can just use the Grails event resource module. Simple. If you inject this module, which is Grails event javascript.js, on your page, now you can start using some API. Basically, you can use this one. New Grails.events is creating for you the right persistent connection to the server. That's all you need. If you want to add some option like binary, true, if you want to mask the frames, the WebSocket frames, for some reasons, or if you send, if you send binary, if you stream your webcam, for instance, you might want to do that with binary. So that's the thing, to create a connection, and that's it. I just pass the root of my application. That's why I create a link using the Grails create link. So that's to declare the connection, the first step of my lifecycle slides just earlier. If I want to now send event, well, first I need to listen on event. So basically, there is an init initializing the canvas where I draw, and after that, I listen specifically on 2 events. And you can see, I can listen on these events because they are declared in my configuration, my event configuration. And the syntax is quite natural. I mean, it's on, like on the server. If I want to listen on start draw event, I just have to declare start draw as a topic. It doesn't support yet all the selector family, so you can only use a string topic on this side. The data, if any, in fact, is passed as a JSON or something else. It depends on the type of data. When you send the event, I automatically transform the type for you. So if it's binary, it sends an array buffer. If it's an object, it transforms into JSON. If it's a simple string, it doesn't do anything. So in that case, it's going to be a JSON, and you will see why. So if the JSON has an ID, and the ID is not my ID, I want to create a line. And the other thing is, I want to add a new point on that line, so I listen to the raw line. And same, if it's not my ID, because I'm going to be part of the subscriber when I send the event. I don't want me to be notified, I just want to discard this. So if it's not me, draw this on the canvas, basically. So that's to listen on event, not very difficult. You see, I didn't mention any WebSocket or SSC or this kind of technology. It's just an abstraction, an event-driven abstraction. And now, the send part. So the send part is basically using send operation and using same, the key, as a first argument. And you can see I send an object, so that's why I receive an object on the other side. And I send my ID, the color, the stroke, the stage, mouse X, mouse Y, to just send the position to the other browser, and the color of my line, etc. So that's quite simple. But sometimes having a server on the middle, you could use WebRTC, for instance, to do peer-to-peer communication between your browser. But having in the middle tier as a web application to intercept your event might help you to filter, process, or even do what we call event sourcing, which is basically the ability to replay events in case of failure. So that's what I've quickly done there, because it's using a concurrent hash map. You won't do that on a concurrent hash map. You will save that on Cassandra, for instance, which is good at event sourcing. But I have a bin, draw service, just zooming a bit. I have a bin in draw service, and I declare non-protected concurrent hash map, because you will see a few things are going to write and read from this. And the selector, which generates the consumer, you can see I use start draw. It's matching the name of the topic. I could have used a value equals start draw to be sure that I'm listening to start draw topic. So every time the browser because I use the Reactor browser. Every time an event coming from this reactor, which basically means every time something is coming from the browsers, on this specific topic, start row, I add the captured data.id, the incoming data, which is by default, because it's an object, interpolated into JSON for you by the plugin. If it was a simple string, you couldn't do that. You should have done that. If it was a binary, you will have to do an empty stream, in fact, to do things. But we send a JSON, and basically, for us, it's automatically transformed into a map or JSON object in Grails. So every new start row flowing to this captures. Every time drawLine is called, I'm also adding a trace. So you can see in the browser, if I start, oops, I need to show you the network events. If I start drawing things, you can see the flow of events. Yeah, you can see I send a bunch of this drawLine events JSON data, which is basically an update on the position and the related ID. So every time I send this list, which is the path of the line, I'm going to add this on a trace. So I feed my trace list. And I've created a replay all method, which is called by this, oops, I replayed, which is called by this replay all Ajax call. And it just, in fact, goes to this replay method, replay all. For every entry in the capture, I'm in fact calling the replay method, which takes an ID. And what I do is I use a server-side injection. So this side is the server send to the browser without any other browser involved here. So I can use directly event method. I use the key start row, which is listened for by the browser, you remember. And because the browser has ext browser, which enables to generate the consumer for the browser, I have to send this to the specific Reactor browser. That's why there is a for. And I send the data, which is a map. And if it's a map, or if it's an object, a complex object, the plugin transforms it into JSON. So that's why, in fact, I'm simulating the browser here just by looping the events back, capturing the event. It's quite, well, it's straightforward, in my opinion, compared to if you have to deal with the stream, with the WebSocket connections. Well, you can do that. It's probably optimized in some aspects. But, you know, having an abstraction is interesting. This level of indirection might be used to evolve, to scale out. For instance, if the shared space is not on your memory, but on RabbitMQ, as I told earlier, all the applications listening to RabbitMQ are going to listen for these events and propagate them to the browser. So all your applications are aware of the events. So that's interesting. That's why you have this level of indirection. And I'm going to conclude just on the few last examples I have there. So I'm not sure this one is quite old, but might work. So that's one of the things you can do. So the first image, for instance, is me broadcasting binary images from my webcam to the server. And the server, like the draw example, is sending back the event to the second image, which is populated on 24 frames per second. Well, you try to, but you know there is a slight delay. It's hard to cope with that delay without involving buffering on your client side, but I didn't want to code MPEG codec, for instance, for that. So this is just binary creating image on your client. And
so that's Google Hangout?
Yes, you can do Google Hangout. You can forward the audio if you want to. It's not very difficult. The API is documented on HTML5 blogs everywhere. It's super simple. I could give my IP, but I don't want to be DDoSed, so anyone in the room could connect. In fact, there is a last example. If I connect to, I use that one sometimes just for the fun and the hand. Oops. Say we have Stéphane 1 and Stéphane 2. Where is Stéphane 1? So, I'm lost. I'm here. So you can see my two browsers are connected. I could use Firefox as well. It's a little game. It's not really. I think I've just taken a lot of snippets from the interwebs and aggregated that, and just added a few methods to decorate and make this application event-driven, just by adding the Grails event to enable the persistent connection and sending the right event. So that's why you have seen fire in my event enable, fire and move. So every time I move, I send an event. Every time I fire, I send something. Well, and that's it. You don't want to see what happens when you die. Yes, let's show that. 20 times. Is it? Why it doesn't die? Yeah. Oh no, it's the other one. Sorry. Yes, basically it's because I'm French. So this one is going to be quite ugly, but for the last minute, I think it's the right conclusion. Tack, 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 tack. What happens now? Well, when you lose, you are a loser. So you have this nice muscular. Well, now there's advertising, but yeah, and you don't want to hear the music, or maybe yes. No. No. You don't want to hear that, so that's it. And I think I'm on 2 minutes left, but if you have a few questions, why not? Any questions? Come on, we're not that a lot in this room, so you can ask. Even a lot in this room, so you can ask. Even in French. Sorry again for that success. Questions? No?
There's one in the middle.
Cool. Yeah. Yes. So the question is, what would you do if you want to send specifically to one user? Is that right? So yes, you can. What you could do is, do I have an example? So you see this one. I bridge using sample bro -star. So that means all my application can listen. All my browser can listen using sample bro -1, sample bro -2 for each different user ID. So you might have a specific ID for a specific topic for each of your browser or user if you want to. And if you want to send to this specific topic, well, you can reconstruct the topic using user ID and the pattern you have here. Just send an event to sample bro -1, and only sample bro -1 will receive the event. So you can use a topic for that. Good.
It's time.
Done. Thank you.
Thanks a lot for it.